is the questions that pertain to clamping, the questions that pertain to that set of questions will have to do with finite difference for the purpose of the exam. So it's just a matter of finding the finite difference. Did you do least squares or not yet? I have not done least squares, but least squares is on the exam. I'm about to get there. So for least squares, it has to do with noisy data. When they tell you something like, "Oh, you're given data that is noisy." So when they give you data that is noisy, you're definitely going to be using least squares. And what they can ask you for a question like this, for a question about noisy data, they can ask you like, "Oh, hey, what if we wanted to come up with a fit function? If we wanted to come up with a fit function that is in the form y of x is equal to ax plus a1x, if I wanted something like this, then I can ask you, okay, what are the values? So what are the values for a naught and a1? But most importantly, something that they're going to ask you is to come up with the equations, like with the set of equation. So come up, this will come first. So this guy come first, and then from this you find the second one. So come up with, you have to come up with the system of equations. And if you recall correctly, the system of equations is something like this. So your system of equation is you have your matrix here, and you have the two coefficients, which those are what you're looking for, and then you have your right hand side vector. So this is one of the equations is coming up with this system of equations, and then the other one it's to actually solve for those values. So that's as far as you need to know for least squares. The other information that you need to know for least squares is they will provide you some information. They will provide you some data that you have to know how to use, and they will provide you two characteristic values. So you have to, as you're going through the exam, there is a lot of extra information that you may not particularly need at that stage, and you have to know how to go through it. So make sure you know how to calculate. I'm gonna say know how to find. Make sure you know how to find r square, which is the, I forgot what is it, the sum of the error square or something like that. I don't remember exactly, but you have to make sure you know how to find r square and how to find the standard error, which I think it's something like SXY. I think that's the notation that they use. So these two guys, you definitely need to know how to find them. You will be asked to find them on the exam. So this is everything sexy. This is this is all that has to do with the first section of the project, or I keep saying project, of the exam. So again, just a quick recap. The three main things, as I mentioned, you will be doing is interpolation, least square, and finite difference. Yeah, I think it's something like that. It's some equation. I'm sure it's on the formula sheet, so you just have to know how to use it. And the information that you have missing, I think is provided to you. So it's just a matter of plugging and doing. But yeah, so make sure you know how to do the Lagrange interpolation, how to come up with the Lagrange interpolator, like with the actual equation with a polynomial, and how to evaluate that polynomial. Make sure you know how to do finite difference of the second order accurate and first order accurate, the formulas on your formula sheet. And all the information you will be provided will be provided in this fashion. It will be provided in the, you have your x vector, and you're going to have the vector of the function, which is the evaluation of that x vector. And once you get to the noisy data, make sure you know how to find the fit function and how to solve for those coefficients, a sub 0 and a sub 1, and also how to come up with the system of equations. And then you have to find the r square and the standard error. That will be everything for section 1. So that moves us to section 2. So section 2, when I was working through it, what I noticed is section 2 has a lot to do with calculate. God, that's a horrible way of writing calculate. So we will be calculating integrals for the second section. So section 2 has to do with calculate integrals, and they will ask you to find the solution. So, or I can say solve integral. So they will ask you to solve integral using 1, 2, or more trapezoids. Yeah, it's gonna be 25 questions. I think it may be 26 unless they remove one of the questions. I think there is a question in there as a bonus or as a buffer, in case people miss any of the other questions. I'm not sure. I saw 26 questions. So yeah, I think the time, I think it's 3 hours. I think the final is always longer than the rest, but don't quote me on that. But I think finals are always longer than the rest of the exams. Yeah, I think somebody was saying something like that during previous office hours or something like coño. Somebody was saying something like that during previous office hours. So definitely email your professor, and or you can email Kasap, or you can email the TAs, and we can always give you the exam earlier. Possible an ethics question or knowledge in that you will submit your strap paper. Yeah, there is a question about that. But anyway, we can talk about this after when I'm not recording. So we're not print. Uh, so yeah, you will solve an integral using a single trapezoid or multiple trapezoids. So you have to make sure you know how to do that, how to find the using a one trapezoid, two trapezoids or more. Then you have to know how to find the error. So you have to know how to find the error between trapezoids. That's what I'm gonna call it. But what it means is if you find the if you do your evaluation with two trapezoids and you do your evaluation of the integral with one trapezoid, you have to compare the error between those two, or you have to find the error between using two trapezoids and one trapezoid. So again, a formula that you can find on the formula sheets. And finally, you have to know how to do calculate. You have to know how to calculate using Romberg. So you have to know how to use Romberg integration. So you have to calculate using Romberg's integration. That will be these are the three, I will say, sections of calculating integrals without taking into account Gauss quadrature. So part of the same section, something that you're gonna see in this is definitely on the exam, as I told you before, is to find Gauss quadratures. And what part of Gauss quadrature can you expect? You can expect to be asked to find the linear mapping. So come up with the linear mapping. Which, if I remember correctly, is something like b minus a divided by 2 multiplied times the psi guy plus a plus b divided by 2. That will be the linear mapping, and a and b are your limits of integration, and psi it's the mapping. What's the word between trapezoid and the second point between? Yeah, between. It's a horrible way of writing between, but yeah. So find the linear mapping, and then you also have to know how to find the Jacobian. All these formulas are on the formula sheet. I believe the Jacobian is just the first part, so b minus a divided by 2. I think that's the Jacobian. This one is the linear mapping, if I remember correctly. And yeah, and then from there, you just have to know how to solve using. So solve using Gauss quadrature. which, as you might expect, quadrature. As you may expect, this means that we will give you, I think they will give you um, your weights, which will be like only three of them. I think you're doing a 3 point Gauss quadrature. It's either a 2 point or a 3 point. If I remember correctly, I think it's a 3 point. And then they will give you your psi values, which of course are not gonna be these values, but I'm giving you, we're gonna 72 people. You should do a review. Yeah, no, not happening. But yeah, so those are your weights. Those are gonna be your psi values. That's what you're gonna be given at that section of the exam, and then that's what you're gonna be using to solve the whole Gauss quadrature problem. So again, this is the end of the second section. So the second section has to do with calculate integrals. You will have to solve integral using one, two, or more trapezoids. You will have to find the error between using a certain number of trapezoids and another number of trapezoids. So if they want the error between using 3 trapezoids and 2 trapezoids, then you have to be able to calculate that. You have to calculate integrals using Romberg integration. And then once you go move into the Gauss quadrature section of, or part of section 2, then you will find the linear mapping, which is the function of x, or the function x as a function of the psi value. And you have to know how to find the Jacobian, and then you have to go ahead and solve the Gauss quadrature by hand. So that is with respect to that. Then I will talk about section 3, which this will be the last section. So the project, I keep saying the project, the exam is divided into 3 main sections. Section 3 has to do with ODEs. With ODEs using, so ODE using Euler's method. Yeah, so the final was project 9 all along. Yeah, so you're gonna be doing ODE using Euler's method, and you're gonna be doing normal Euler's method. So Euler's. It's so confusing whenever I'm writing Euler's, because I have the tendency, if I'm speaking in English, I have the tendency of call it EU, but because I took German, I took 4 years of German, then I know it's OI. You pronounce that as OI, EU. So yeah, you pronounce OI. That's why it's called, when you say Deutschland, even though it's written as this, you call it Deutschland. Okay, but anyway, uh, normal Eulers and modified. Normal Eulers and modified. That's reviewing. Normal Eulers and modified. So make sure you definitely know how to do this, to do normal Eulers and modified Eulers. Modify Euler's method. And the last question, the last question that I saw on the exam. So other than this, guys, other than solving using normals, Eulers, modified Eulers, what's something of using, so using the shooting method for boundary value problems, for boundary. And this is somewhat of an advanced topic, I will say. So it's nothing extremely complicated. It's something like, for example, if I gave you, and I'm just pulling this example out of my ass right now, but this is, if I gave you something like the deflection of a beam, which it has this form. If you have something like this, and let's say I call that my function, and this function belongs to, so it's a finite beam. It goes from 0 to L, which is the length. And then if I gave you some initial conditions like, oh, the displacement at 0 is 0, and then the force, and of course the area and the Young modulus changes because we're not in solid mechanics. and du dx evaluated where x is equal to the length. This will be an f naught. So that will be, wait, go back. That will be, there you go. So that this will be, this is the equation of the deflection of a beam from 0 to L, and then I have some initial conditions. What they're gonna ask you to do primarily is to come up with, you have to use finite difference and for the boundary value problems, and you have to come up with an equation, like with the actual equation. So the idea is that you use boundary value problems to solve differential equations. That's pretty much the case, and this is kind of like the beginning of something like finite element or those advanced classes, but you have to use boundary value problems to solve the ordinary differential equation, which means you're gonna move things around, you're gonna integrate, there are different ways of going about this. I don't know what method exactly they expect of you in this class, but this is one of the questions that is there, and they just want you to come up with the equation. So so you have to come up with the equation. They're giving you differential equations. You have to come up with the equation. I'll just take the L for that one. Can you say how many questions per section? I think it varies. It varies. Some of the there may be some conceptual questions in there which have to do. I think I saw like one or two conceptual questions that had, hmm, it has something to do with the, like if you needed like local evaluation of the first derivative or something like that. I'm sure a question that you saw in class. Serious question. Why are we doing that advanced OD stuff at a coding class? Because this is not a coding class, this is a math class. It just has coding in it, like everything else that comes after this. 1/3 will be fair to assume, I will say. They're divided into 3/3. So the first, that's why I divided into 3 sections. I will say each section has equally as many questions as the next one. So maybe if you're not good with the integral section, it's not like it's gonna be a bigger part than the interpolation and least squares. I've not learned any math in this math class till this last ODT. Yeah, that's what happens. You usually don't. Yeah, I will say you don't learn anything with respect to this class until you're done with the class, and then you see it in a different class and you have to learn it. But yeah, that is everything with respect to this, with respect to the exam. So I'm just gonna scroll up and down real quick just to kind of like recap, and then after that I will stop the recording, and then we can answer some questions. So this doesn't go on forever. But yeah, so the final exam review, again, interpolation, least squares, and finite difference will be section 1. They will give you your data points. You have to know how to find the Lagrange polynomial, how to evaluate the Lagrange polynomial. Then for the clamp condition section, you have to find the you have to use finite difference to evaluate those first derivatives at those endpoints, at those clamp points. And for this, we're gonna use the finite difference method. You can find it on your formula sheet. Then once we get to the noisy data, you have to be able to come up with the fit function. For the fit function, you have to be able to create the system of equations that you will use to solve those coefficients, and then actually be able to solve those coefficients so you can report those as an answer. And you have to know how to find the R square and the standard error. Those formulas, I believe they're in your formula sheet, and you will be provided all of the unknowns that you need to calculate the standard error and also to calculate R square if they're not obtained from the previous questions, which I don't think they are. So section 2 has to do with calculate the integrals. Make sure you know how to solve an integral using one, two, or many trapezoid, as many trapezoids as they want you to use. You have to make sure to find the error between those trapezoids. So find the error between using one method and the other method, and calculate those integrals using Romberg integration. And then the final part of the section 2 has to do with Gauss quadrature. Gauss quadrature, I've been telling you guys for a while that make sure you know how to do it by hand, and you have to know how to find the linear mapping, which I believe that is the equation. If not, the equation should be provided in the formula sheet. The Jacobian, you have to know how to find the Jacobian, and then you have to know how to actually go ahead and solve for the Gauss quadrature. So they will give you a set of weights and a set of psi values that you have to implement, and you have to carry on the process by hand. If all of this is new to you and you haven't seen it a single time, definitely check out Numerical Methods guy on YouTube. He has a bunch of videos of these different methods with examples. So make sure you go and look at that. But section three, which is the last section, ODE using Euler's method. So normal Euler's method and modified Euler's method. Those are the two big guys in this section. And then there's one question. So the normal Eulers and modified Eulers, that will be the big chunk of this section. The shooting method for boundary value problems, it's only one question, if I remember correctly. And it's a question similar to this. It's not necessarily this, but it could be any type of second order problem. It could be a vibration problems. I think this one is a deformation of a beam, and they will give you the differential equation with some boundary conditions, and they just ask you to come up with the equation that represents this system, and that's it. That will be everything for the final exam. So I'm gonna stop the recording now, and I'm gonna answer some questions. There you go. No, the other TAs are not doing reviews. Sadly, I'm the only one doing a review, but not really a review. So the problem is, number one, I know that they're busy. I know Milan usually is the one who makes the review other than me, and she's more of, she likes to do problems like workout problems and things like that, but she has her own finals at work, and so I think this week is actually chaotic for her. So that's probably why she's not able to do the review. I'm not sure if she's gonna come up with something like maybe like she did in the second one. Um, it just office hour for 74 people. Yeah, exactly. I think the she may do what she did for exam two and create like a PDF or something, or something like that that she sent out. I think she did, and that may contain some examples. But I really have no idea. I haven't talked to her. Don't hold your breath for that, guys. Could you set out this document for us? Yeah, just send me a message on web courses and I can send it. The PDF was so nice. Yeah, it was a pretty good PDF. I think that that was something that I really like doing with her, because she will like, I normally just talk about what's going to be on the exam and things like that. And I like to spend more time doing just explaining the theory. She likes to actually work problems. I will work the problems. The realities I don't remember because I haven't seen. I know this stuff, but I never do it by hand. I just do it on the computer. Yeah, that's the problem. And I think the only examples that there are the ones on the book, and those are not the most helpful. I can do examples. I can do them. I don't know if I can come up with the correct answer because I don't remember the. You're very welcome. I really have no idea how to do some of these things by hand. I honestly, I will say just look at the formula sheet, and that should give you. Let's see. Um, where the formula sheet? Okay, here. Oop. Okay, so for a given set of data points x and f, this is what they're gonna give you on the exam. They're gonna give you your data, your x, and your evaluation. The Pn, the Lagrange polynomial interpolation, and the n, or the Lagrange interpolator. Yeah, so it's L. This is what they ask you for. So this L and K, this guy goes in here and it multiplies the function, and that's how you get this is how you get the polynomial interpolation. But the Lagrange interpolator, that's what they ask you to find. And this is all a multiplication. So this x never takes any value, but the xi, that's the one that will change depending of how many. Let me see. So I starts at 0, and I cannot be equal to k. So k will have whatever value it has, because if I and k are the same, this you will divide by 0. Big pi is a multiplication. So let me see if I can move this over here. You'll probably won't like that. I think you guys probably cannot see that very well, but the idea is that if you're doing something like this, if you're doing something like L2, and let's say like L22 of x, I don't know why it lags so much when I make it small, but, and I starts at 0, I cannot be equal to k, and n, it's gonna be the max number of the polynomial. So what what I'm doing here is you're gonna take those values from the L that they're giving you, like the L on the left is giving you all of the information that you need. So I cannot be equal to k, so I cannot be equal to 2. And, or you can just leave it as k if you want. I is not equal to k, and n in this case is 2. So what happens is you're gonna multiply, let me just write it like this. And this is all of memory, so don't judge me. I've probably haven't done this class in years by hand. So L2, it's gonna be equal to, I'm gonna have my first one, which is x naught, and then k in this case, if I remember correctly, I think this is n and I think this is k. So this will be x2 minus x naught. Then I'm gonna multiply by the second one. The second will be x minus x1, and this will be x2 minus x1. And now the next one, you don't write it. This is as far as you go. Let me see, I cannot see the chat, so I don't know if you guys are saying something important. Since they will give us the initial value, since we need, yeah, so you will be given, it's like the summation will multiply. It will be nice if we work an example. So the big P is what, yeah, it's like multiply. I don't know if you guys can see what I'm doing here, but this is what you're doing. So the n will tell you the degree of your polynomial, which if you think about it, this guy is a value, this guy's a value. Like they are actual numbers. That guy is a number, this one is a number, this one is a number, this is a number, this is a number. So if you take all of these guys as numbers, you have x, which is the only variable, multiplied by x. So the degree of your answer will be 2. This will be a second degree polynomial once you multiply. So that's kind of like how you go about solving for this, guys, depending on what they tell you. If they tell you L1, 1 of x, then here I know that n is going to be equal to 1 and k is going to be equal to 1. Again, if I remember correctly, I think the one on the left is the n, the one on the right is the k. So the one on the right will never be higher than the one on the left, but n can be higher than k. So what this will be x minus x naught. You always start counting from 0, and then this will be x1 minus x naught. Now I cannot multiply by the second one, because if you, what you can do is, if you really don't understand this, you can just keep repeating this equation, this one you see right here, keep multiplying it, increasing one every time to these two guys, to the one on the top and the one on the bottom. The one on the left, the value of this will depend on K. This one on the left will depend on K. So if K is 5 in this case, then I have to change this guy to 5. And I have to keep going to as this tells me, at the end tells me. So the end will tell me how many multiplications I am carrying out. And in this case, it will only be one because of course it makes sense. If I try to multiply by what comes next, which is x minus x1, look at the bottom. The bottom will become x1 minus x1. So I will be dividing by a zero. The bottom will zero out. I will be divided by a zero, which is I'm not able to do it. So that's why you just leave it here. So L1 x1 will be that. If I wanted to do something like L3, and then this will be something like 1, for example, which you may see something like this. In this case, n is 1, k is equal to 1. I'm sorry, n is 3, k is equal to 3. So this one might be a little tricky because we're going to be skipping one of them. In the homework solution, they started at x1. You can start at whatever. It's just an index. Is k, then it's not wrong. Yeah, it all depends on where you're starting, or I'm sorry, it all depends on what k is because you will skip k. That's why there is this little guy here that says I cannot be equal to k. You have to respect that rule. I can never be equal to k. So in this case, if I wanted to do my 3 multiplications, at some point I have to go through 1. At some point x has to be equal to 1, but I can't. I won't let that happen because I cannot be equal to k. That's one of my conditions. And the other condition of that multiplication is that I starts at 0. So what I am going to do is I'm going to start with my first multiplication, x minus x0, and then k is a 1. So this guy, the guy on the bottom left, this one will be x1 minus x0. Now the second one, I will skip the one that where x naught is supposed to become x1. I will skip it because I cannot be equal to k. These guys on the bottom cannot be the same. So I will skip to the next one. So this will be I minus x2. You see how I skip the x1 because I cannot be equal to k. And then this will be I x1. This guy always stays the same because this guy is xk, and k never changes. K is always the same value. So this one always stays the same. So that will be x1 minus x2. And then the last one will be x minus x3. And then x1 minus x3. And if you look at this guy is the variable, this guy is the variable, this guy is the variable. So this will be a third degree polynomial. Shit, I'm not writing this correctly. This will be a third degree polynomial, and which is exactly what the n value is. N value, it's 3, so I'm supposed to have a third degree polynomial by the end. So that's how you do that multiplication business. So just keep in mind, a cannot be equal to k. If you get a 0 on the bottom, if you have like xk minus xk, absolutely wrong. You're not doing it correctly. So yeah, here they give you for n equals to 1. So in this case, n is equal to 1. The data is given. And so you have the 2 points. They will always give you 1 point more that your n. So L0, yeah, L naught. Here's an example. Here's an example of how to do it. I guess they're not the best examples, but you know. And then you have to plug in those values. That's how you find the interpolator. So once you find this L, then you just have to distribute the L inside. Yeah, they're using 2 interpolators. Very interesting stuff. So least squares, given a set of least squares, given a set of data pairs. Blah, blah, blah. So all these equations you will use it. I think particularly this one. I don't remember using this one, but it's good that you understand it regardless. But I think this is what we're using only. Define the sum of the square of the errors. Yeah, I think you were given the data pairs. and the approximation of the function, but you were not given the coefficients. You have to find the coefficients, define the sum of the square of the errors, minimize with respect to the coefficients, and solve the resulting equation for the coefficients. Yeah, you do have to find the coefficients. This is one of the things I remember. Yeah, I remember saying this. Case 2, the an approximation function is nonlinear function of unknown coefficients is the system. Yeah, I don't think we, no, they ask you for a linear fit. They don't ask you for that. Yeah, they ask you for a linear fit. They don't ask you for a nonlinear fit. But you need this equation. This one you have to find this, and you have to find this R square. Those two you have to find them. And finite difference. So here's the forward finite difference, and I guess they look slightly different than on the first formula sheet, but it's the same thing. It's y is the evaluation. So I plus 1 is just the evaluation at the next one, at the next point. Y minus yi, that's the current point. So if I'm evaluating at x1, this will be my current point. This is my point in front. And this will be the forward finite difference. So you can see how they're different. Look at how they're different from what we saw on the first exam, how they have the delta x square and the delta x square. That's because these guys are the second order accurate. So this will be the second order accurate. So here's their forward, backward, and central. And this one is the second derivative. The second derivative only has one equation. So if they ask you to find the second differentiation on the exam, you have to use this for the finite difference section. But the finite difference section is literally just plug and chug. Like there's nothing crazy to it. Just if you see I plus 2, it means 2 steps ahead. Instead of only being like the value in front of it, it will be the value after. So quadratures, this I hope to God that you guys know how to do this, because I ask a lot for this. What is the O del X? That's the higher order terms. ODX just means higher order terms. We talk about that on the first exam. It just means when you do the Taylor's polynomial, and when you are doing the Taylor polynomial expansion and you chop it right before the second derivative, we take all of those terms that come after in the infinite of sum of the Taylor polynomial expansion. You cannot just drop them. Like you have to group them and call them something. So we call them the higher order terms. When you're doing this by hand, you don't include this. You can just ignore it. You just ignore that. So this is all you want. Only the part that is before the O, the X. So this one for your quadratures, again, you have your weight, your function. Uh, you don't really need that. You just need to know. That's a horrible example. Um, you just have to know that you have to take your weights and multiply them by the function. So it's an interesting step. This is what you're doing pretty much. This is what you're doing. So this is called a linear mapping. This one x psi, you will be giving your values for psi. And what you do is you plug in the value for psi and you calculate your x. Your x will be your mapping. This x goes inside of your function. That's what we're doing here. This x goes inside of your function. So you have, let me see if I can write it here. So you have your values for your psi, and you have your values for your weights. So you have your psi and your weights. You're given your a, your b, which are the limits of integration, and you're giving your function. You're given a function in whatever terms, f of x. So what you're gonna do is, let's say I want to do a 2-point Gauss quadrature. So if I want to do a 2-point Gauss quadrature, what I am gonna do is I will take the first value. So I'm gonna take my first value of my psi, So I'm gonna find my first x, and this x will be b minus a divided by 2, multiply times the first of the first psi value, and then b plus a divided by 2. Again, this is all information that I have. And now I'm gonna take this value, this xi. I'm gonna call this t1. I'm gonna take that value and I'm gonna multiply with the corresponding weight. Like I will take that value and I'm gonna plug it in my function, in the function that I'm given. I'm always given a function, and I'm gonna multiply by the corresponding weight. This guy is considered my first block. You can call it like your first section, your first block, whatever you want to call it. So I always do this separate. So that will be my first block, and then I will do the same for the second x because I'm doing a 2 point. So this will be b minus a divided by 2. I'm going to multiply by the second psi value that I'm given, and b plus a divided by 2. Then I'm going to calculate my second section, which will be the second weight, multiply times my function evaluated at my second x. So this one will be, we'll evaluate there. And that will be my second block. So it's always easier if you kind of like separate it into sections. And you please give me another page. Thank you. And so this what makes it easier here is that now that I know I'm doing a 2 point Gauss quadrature, so I need to add these two guys. So what I'm gonna do is I say, okay, the calculation of my integral from a to b of the function f of x dx will be, I will multiply by the Jacobian, so b minus a divided by 2. You should never forget that. And I'm gonna add t1 plus t2. And that will give me my Gauss quadrature. So that this will be the result of my integration. So that will be the result of my integration. So it's easier if you separate it into kind of like sections. So you go one by one through all the values of the psi and through all the values of the weight. And I will say, what's the word after second? Second block. So I usually call them block. You can call them whatever you want, or you can call them T1, T2 if you want to do it that way. You can also do everything in one go, but again, you have the chances of running into an error or something like that. So normally what I do is I do my first mapping, finding the x, it's called a mapping. And so yeah, exactly. So at 3 point Gauss quadrature will be, I will have to find a third mapping. So x3, which is a function of psi, will be b minus a divided by 2, multiplied by the corresponding psi value, plus b plus a divided by 2. And then we take that x value and we plug it into the function, and we multiply by the corresponding weight. And that becomes, this whole thing becomes t3. Yeah, you're given a and b. A and b are your limits of integration. What's the word to the right of 6? Do I have a 6? Where do I have a 6? I think that's B. I don't think that's 6. Sorry. I try my best to write things in a not very cursive. If it was me, I will be writing A like this and B like this at the top. Yeah, this is supposed to be a B. It's not a 6. Definitely check your check your higher check your formula sheet for clarification. Oh yeah, that's a Gauss. This is Gauss. It's a 6 aus. Yeah, that's 2 point Gauss. PS5 will be given. What is PS5? PlayStation? Free PS5 PlayStation. Probably 500. I hope so. If it's 500, that's very good. $4.99. Let's see. Let's see what else is in here. PSI. What is PSI? A unit? The router of doom versus the fridge box. PC2. You forgot the truncation error for the price. Pounds per square inch. Yeah, maybe we're given the PSI. So you will be given these values, by the way. You'll be given the psi values and the weights. I think that's what he was trying to say. Yeah, you're given the weights and the psi. You don't have to pull them out of your ass. Trapezoidal. So basic rules, you will be using this, guys. Some of them will ask you to use trapezoidal, same some midpoint. It's just a matter of using this. Just a matter of plugging and using. Yeah, he meant psi, I think. So that was more of a do-it-yourself example. Yeah, the examples on the formula sheet are crap. So I will not rely on those. But yeah, so basic rules, compound rules. Make sure you definitely know how to do the compound rules. Error estimate, this you will need. This you absolutely need. For a compound with t is the value component of, you will be using this in one of the questions for compound trapezoidal. So what you do is you put the 2 in here, and when you put the 2 in here, this becomes a 4. So this is the error between using 2 trapezoids and 4 trapezoids. So just put the lowest value, and this guy will multiply by 2. Same thing here when you're calculating the error using the Simpson's rule. So you're definitely using that. You're definitely using Romberg integration. You will see Romberg on the exam. It's supposed to be a visual learner. I don't think such a thing exists. Jesus, this thing is glitchy now. I mean, hell, because ban me, please. Will it be to review to do a trap example? I feel attacked. What are you guys talking about? You ain't writing that. Yeah. So what I was trying to say is, if they ask you to find the error using compound trapezoid, so if I'm doing compound, so if I'm doing the compound trapezoid error between, I can still not write it correctly. So compound trapezoid between 2 and 4 trapezoids, then the error function becomes the error of 2. It's going to be equal to 4/3 absolute value of T2 minus T4 in this case. And where do you find T2 and T4? You have to do the compound trapezoid. So you have to use the compound trapezoid to this one to evaluate that integration. Usually at the end of that integration, we call that T, and then T, and put the number of whatever, however many trapezoids we use. Yeah, so if you're doing a compound trapezoid with 2 trapezoids, it will be T2, and then you will write this function up here. I think that's how it is, if I remember correctly. And same thing with the Simpsons rule. Romberg integration, same idea. You will see it on the exam. Romberg integration is in a 10-step. Oh, Jesus Christ. The MATCAT code we use for generating. Yeah, how about now? But yeah, you will see Romberg integration on the exam. Tableau. Romberg estimate. ODEs. So discrete time, Euler's method, you will definitely see Euler's method. You will definitely see modified Euler's method. I think the trapezoidal method is the one that you will see. And then you will see the error estimate. You will have to use the error. Anyone feel really bad about this exam, or is it just me? No, this one is gonna be easier than the second one. Honestly, I wouldn't. I think the second one is the hardest one. Yeah, that's the thing. If you took linear algebra or something like that, the second one is the easiest. But I don't know. I feel like this one is primarily just like know how to follow the process. Kind of like if you think of Gauss quadrature, you think Gauss quadrature is extremely difficult. It's like no, it's just be organized, like down. Isn't that from the Detroit Become Human? Um, but anyway, yeah. So you just have to know how to be like organized as you're going through the exam. Lots of writing. That's exactly what it is. Will the material be today's lecture? No, I don't think. I think the material from today's lecture is just here. Uh, it's just for you to. Yeah, I think it's from ALA. Down your console. Um, I don't know. I've been watching a lot of Detroit Become Human. I'm extremely close to just buying it on my computer. But yeah, I don't think the lecture from today. I think it's just gonna be him saying bye and telling you guys what to expect on the following courses and what kind of stuff you're gonna be seeing. 2077. Oh, I'm definitely playing 2077. What's up with that quiz though? There's a quiz today? It's a fun story, but I don't know the game how much. Oh my god, that's horrible. I wonder what the quiz is gonna be about. Last two lecture horrible. Yeah, I definitely cannot help you on that. Pure dynamics worse than can you imagine giving him 48 hours. Make him delete it. He's playing his email. Yeah. I'm sure he's not gonna make it that difficult. He knows this is the last day. Can I work a romber and least square problem? I have no idea how to do this guy. For compound trapezoid rule using a subdivision, then the romber integration formula is uses step size. T2 uses a step size. Huh. Hmm. He will punish. Who said Kasab drops half of the quizzes? You guys only drop one quiz, one class quiz, and one project gets dropped, which I think it's already dropped since the beginning of the semester. Bit average velocity. It's true that Kasab dropped. My way to drop is many to drop the class. Quiz is gay. I do good on tests, so yes. It's true that because I replaced the two lowest test grade with her highest score, speech 100. Yeah, he's not replacing shit. I love every semester. There is a, I don't think I have the picture anymore. There was someone, I think on the fall semester last year, who emailed Kasab and it's like, is there, I skipped the exam, something, something. Is there any chance that you can reschedule or something? And Kasab literally just sends him an email back saying no. And he's like, cool, sick, thanks. Oh yeah, he's a wall that doesn't break. I will break before that guy ever breaks. He doesn't he have like 5,000 or something like that? I know he ignores emails. Like, holy shit, 140,000. That's a lot at the beginning of the semester. Yeah, I don't think he ever checks his email. It's so funny. Yeah, I don't think I know anything. Least squares. I wish I could help you with least squares, but I really suck at least squares. I haven't done that by hand in a very long time. Spam newsletter. And but I am almost positive that it's a linear fit. There's not gonna be non-linear fit. Fit off, yeah, no, it's gonna be linear. It's in the form. It's exactly how I said on the preview. Let me close this guy. When I try to look, no problem. How much work should we show? Show as much as you can. If there is something that you can skip by doing it on the calculator, I will do it on the calculator. Just be careful and try not to be like extremely smart, because calculators use their own, they use their own like routines and things like that, so they might be different than the answer that you could get by hand. So don't use your calculator to integrate or anything like that unless it has a way of doing Romberg integration. Like if it's something that can save you time, I'm all for it, but be careful. I have no one to do work for Google Pieces. Try not to be too smart. Yeah, being too smart it's pretty bad. So keep keep it reasonable. Wait, I think did I close my? Oh, it's still there. Okay. But yeah, I'll send the review. So if send me an email if you want the review, or if anything, if somebody can post it on GroupMe, that will be even better. So I don't have to go there and post it myself. I think my name is still 4K Porn Workstation. So if somebody can go in there and post it, that will be better. I don't have to do it myself. Well, I guess that's all that I have. So that in the group chat, I got confused. That's all that I have. So if you have any questions as you study, I'll do my best to answer as many emails. I honestly, I think the final exam is 3 hours, but it will prove 6 hours. I don't know. Some students get more time. Post it on YouTube so we can make some easy money. I'm not making any money out of numerical methods. Nobody watches this shit. What time does the exam start? I don't know. Let me see. Isn't it on Thursday? It's on Thursday at like 2 p.m. or something like that, isn't it? My other finals. What is this? You say that, but look like numerical methods guy. My other, wait, what am I looking? Oh, it could be you. Actually, today, damn, someone class. I have 5 now 4 p.m. on Thursday. Say starts at 1. I'm pretty sure it's just during class time. Does it start 1? Let's see. Uh, let me see. Give me 1 second. I cannot. For those with SAS, it starts out. I see. Did I just see Project 9? Yeah, there's a bunch of projects. Oh, okay, yeah. So people that have the SAS, it starts at 1, and for everybody else, it starts at 2 p.m. and it closes at 3:50. What is this says? I think it's a special accessibility for students, something like that. It's for people that have like anxiety during exams and things like that. Special air services. Yeah, it's a subdivision of the Air Force. I'm pretty sure it's during class. Blah blah blah. What is this? A student accessibility service. That's what it is. He did it for the win. SAS. Wait, getting crippling anxiety during exam isn't normal. It's actually pretty normal. It's just some people use it for getting more time and things like that. We all went through anxiety usually for students with attention issues. Yeah, exactly. Just drink alcohol. I think, in the exam. I remember. I think when I took modeling method, I used to have very bad. Like I will freak out during the in the middle of the exam. Have I anxiety to do anything like that? Honestly, everybody has them. Everybody has anxiety during exams. Like it's so sad, but it's also so common. I need to apply for that. I got attention's part of an ENET. So cute. Um, but yeah, I mean, it's normal. Some people use it. Some people really need it. Some people don't really need it. So it depends on people. Eat chunky peanut butter. So people who don't have it, your exam is gonna start at 2 p.m. all the way to 3:50. Yeah, correct. Common because there's 80% nobody doing statistics. quit, smoking, quit smoking salmon. If you go to Coco, you'll find more. Yeah, I mean, oh boy. I will actually. I'll make an announcement. I do have office hours before grades are due, just for everybody who's failing. I'll probably just recycle the same announcement from last semester. Stress relief officer. About 2:15. Disclaimer on it. Disclaimer. Oh, you remember that the disclaimer of the disclaimer, which